Alright, today is Wednesday, March 21st, and I'm going to give you guys a quick recap in case you are taking a quiz or feel like you need to see any part of this lesson today again. We're going to start, the point of today, let me start with that, is for us to find exact values, so trigonometric ratios of specific angles. Okay, and we're going to start with a relationship here that I've kind of hinted at over the last few days, but I haven't focused on totally. And the first thing is that if we have our unit circle here, so again, imagine that we have our unit circle and that our radius is 1 unit long, that really what this means is that we can plot the point or the coordinate through an x and a y. Okay? And so there are a few things that kind of pop up here is for any given angle that we have here, again we call our unnamed angle theta, or our that's typically what we call it when we're not talking about a specific angle, we're just talking about a relationship. And so if this angle that I just highlighted was theta, then sine of theta would be opposite, which would be our y value, over our hypotenuse. So sine of theta is equal to y over 1, which is just equal to y. So if sine of theta is equal to y over 1, then we have this ordered pair, this xy ordered pair. We can say y is equal to sine of theta. All right. We can also say that cosine of theta is equal to, so cosine of theta is equal to adjacent over hypotenuse, which would be x over 1, which is just x. So our x value is equal to cosine of theta. Alright, and so using this, we can say, we can kind of go the other direction. So in our, I'm going to kind of start with this column right here. We can see that sine of theta is equal to the y value of an ordered pair. Cosine is equal to the x value of an ordered pair. If we look back over here at this triangle, you can see that opposite over adjacent, or tangent, would be equal to y over x. We could also say that this is equal to, since y is sine theta and x is cosine theta, we could also make this association. Cosecant is the inverse of sine, so instead of y we would say 1 over y. Instead of x we would say 1 over x. Instead of y over x we would say x over y. Alright, and so this is where we need to have our unit circle available. We're going to look at quadrant 1. And the degrees as things go around are 0 degrees. We have 30 degrees, we have 45 degrees, we have 60 degrees, and we have 90 degrees. In radians, again, I've got the unit circle pulled up right here next to you guys so you can kind of look back and forth. It doesn't look exactly like the one we're most familiar with, but all the important information is there. 0 degrees is 0 radians. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. Okay. Now since I taught this in class and this is a little bit of a reteach, I'm not going to take too much time. But this first column here is looking for the sine values, and what we did at the top of these notes was we said the sine values corresponds with the y value of the ordered pair. So we can say very quickly that sine of 0 degrees, the y value would be 0. Sine of 30 degrees, the y value is 1/2. Sine of 45, the y value is root 2 over 2. 60 degrees is root 3 over 2. 90 degrees is 1. Cosine is simply the x values. So we circle all the x values. We're going to go in this order. So cosine is 1, is root 3 over 2, root 2 over 2, 1/2, and 0. Now there's a relationship between kind of what happens in these two columns. I'll let you kind of look at that and explore it. We talked about it in class, but I'm not going to take too much time with it right now. All right, our tangent values. Let me erase these over here. We said tangent is y over x, or it is sine over cosine. I'm going to use the sine over cosine relationship right now because I have these things lined up, and I'm going to change my color right here. Here's my sine and my cosine. And so it's very easy for me to look at those since I have them right here. Sine over cosine would be 0 over 1, which is 0. And I'm going to, out of the interest of time, I'm going to speed things up and just kind of breeze through this. But you can see what I'm doing. I'm saying sine over cosine. 1/2 over root 3 over 2. We would need to simplify that, and it would end up giving us root 3 over 3. Anything over itself simplifies to 1. Root 3 over 2 over 1/2 simplifies to root 3. And 1 divided by 0, or 1 over 0, is undefined. Cotangent. If tangent is y over x, cotangent is x over y. And so, again, another way we can think of this is instead not sine over cosine, but cosine over sine. We would end up here with 1 over 0, which is undefined. We would end up with root 3, 1, root 3 over 3, and 0. Taking the reciprocal of secant and cosecant and simplifying. Again, I'm going to write these in very quickly. You guys can do the legwork to figure out how I came up with these, but it's just the reciprocal of its other pair. So here we have 2 root 3 over 3. Oh, I'm sorry, I got ahead of myself. This is root 2. This is root 2. This is 2. And 2 root 3 over 3. This is undefined. And this is 1. Alright, I'm going to stop right here. And my next video is going to be the worksheet that you guys are going to work on what would be Thursday, March 22nd. If I ever use this video in future years, guys, disregard those dates. That information and the content will still be the same.